column 102, 102, 102, 10.2, 102, 102. Probably 102 on Leetcode. Binary tree level order traversal. So this is a medium. It's a Friday. I felt like today I was going to approach just maybe an easier problem to get me hyped up for the weekend. Last thing I want to do is get stuck on a hard and then spend the rest of the week contemplating my entire life. But with that said, let's just get right into the problem. So binary tree level order traversal. Okay, so yeah, this is pretty approachable. This seems pretty approachable already. Let me look how short it is. Given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. Okay, so we're given this example. So let's just go ahead and go through it. So we have 3, 9, 20, 15, and 7. So the first level is here. So the first level is here, 3. The next level is here. So the next thing is here, 9, 20. And then 15, 7. Okay, so we're going to be searching on this binary search tree. We're going to start here at the root. Now what I think we want to basically do is BFS, or breadth first search, because breadth first search naturally will kind of align with this level idea, right? Because when breadth first search occurs, it'll look at this, or I guess, yeah, breadth first search occurs. It's going to look at this node first, and then these two nodes, and then these two nodes, naturally, right? Because how breadth first search essentially works for any kind of tree setup is it always looks at everything at one level before continuing to the next level. So the way breadth first search would look for this node is it looks at this one first, then it looks at its neighbors on the queue, this and this. So this one is finished. So if I did it one by one, it would look at this one, add its neighbor, this one's finished. Look at this one, add its neighbors, now this one's finished. For this one, look at its neighbors, now this one's finished. This one, look at its neighbors, no neighbors. This one, look at its neighbors, finished. This one, look at its neighbors, now it's finished, there's no more on this level. This one, look at its neighbors, no more. Look at its neighbors, no more, no more, no more. So the way that breadth first search will basically work in this case is we'll create a queue, which is the root. And then there's while we have something in the queue, we'll expand or add everything inside of the queue is at that layer or at that level. So append levels with queue, and then we'll explore queue to update with neighbors of a levels thing here, and then return levels. So basically we look at whatever's in the queue here, right? In this example, it'll start with just 3 in the queue. These neighbors will get added to the queue. So we start with 3 in the queue, we add that to the levels. Then we go add the neighbors, then we add that to levels. This is so sloppy, I'm sorry. I'm trying to go through this video quick today. Then we add the neighbors and add that, and so on and so forth. So I think that's the gist of it. So let's go ahead and try to implement an example of breadth first search. Okay, so level order. So queue is the root. Wait, can the queue be empty? Yeah, it can. Okay. So if not root, return nothing. Okay, and then we'll just go here. So queue equals root. While queue, so while there's something in the queue, we'll have levels here be empty. Levels append a copy of the queue as it is. And then we'll say queue equals the neighbor, or I guess since it's a binary search tree, be a child for each node in the queue, for each child in the node's left and the node's right. So for the node's left and the node's right of the current item in the queue, if that child exists. And then we return levels. Okay, so it's looking like I need to do the queue's value, not the tree itself, just the value at the tree. So lambda node, so for each node, just the node's val. Now that's going to be a map and not a, oh, I guess it doesn't matter. If it's happy, I'm happy. Oh, it looks like I've done this problem before, a long time ago. Okay. Well, that's how it goes. All right. Thank you.